So 1.7 cubed means 1.7 times 1.7 times 1.7. But this is a calculator paper, so I'm just going to do 1.7 cubed in my calculator. Now the cubed button's up here, just the X with a little 3. If we press that, we get the cubed symbol, press equals, and we get a fraction. We don't want that fraction, we want it as a decimal, so press the SD button, and that's 4.913. If you did 1.7 times 1.7 times 1.7, you'd get the same answer. That's what that means. Okay, for the next one, draw a chord of the circle. Now, the line from the middle to the edge, that's the radius. The line that goes all the way across through the centre, that's the diameter. But any other line that goes across the circle and just touches at both sides but doesn't go through the middle, that's a chord. So this is a chord. You don't need to label it, but just so that we know, that's a chord. A bowl contains 1 apple, 1 banana, 1 orange, 1 peach. Jess takes 2 pieces of fruit from the bowl. Write down all the possible combinations of fruit that Jess can take. So we're going to go through this logistically. We can take an apple and a banana. And I'm not going to write it all out. I'm just going to put AB for apple, banana. And then I can take an apple with an orange. And then I can take an apple with a peach. And they're all the different combinations I can take with apple. Then I can take banana with an apple, but I've already got that one. Banana with an orange, and banana with a peach. Then I can take an orange with an apple, but I've already got that one. An orange with a banana, I've already got that one. And an orange with a peach. And then I can take peach with apple, but I've already got it. Peach with banana, but I've already got it. Peach with orange, which we've already got. So that's it. We're completely done. There are 1, 2, 3, 4, 5, 6 different options. Here is a regular hexagon. There are 6 identical hexagons. 3 of the hexagons are joined to make shape A. The other 3 are joined to make shape B. Which shape has a greater perimeter? Now remember that the perimeter is the distance around the outside of a shape. Okay, the distance around the outside of a shape. They've not actually told us how long each shape is, but it doesn't matter. We're just going to say that each of these sides, because it's regular, we know they're all the same length. So we're going to say that this is 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, and 1 unit. And then we just need to count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units on shape A. So I'm going to write shape A equals 14 units. And then for shape B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So shape B is 12 units. Now, what's really important on the Maths GCSE is that when you're asked a question, you answer it. So it says which shape has the greater perimeter, shape A or shape B. It's not sufficient just to say 14 and 12. You need to say shape A has the greater perimeter. So we're answering their question and we're backing it up with the maths. Tom says ABC cannot be a straight line. Explain why Tom is correct. So angles on a straight line add up to 180 degrees, and 146 add 32 is only 178 degrees. Okay, now it's not enough just to say 146 add 32 is 178. You are expected to explain to the examiner that you understand that the angles on a straight line should add up to 180. It's not okay to just get, well, they know that, so I'm just going to tell them it makes 178. You need to say both of these things in order to get the mark. Question 11, Daisy thinks of a whole number. She multiplies the number by 3. Daisy's answer is 34. Explain how you know that Daisy's answer is wrong. So we know it's wrong because you can't multiply a whole number and get by 3 and get 34. So you could say 34 is not in the 3 times table, or I'm going to say it slightly better and say 34 is not a multiple of 3. If we do 34 divided by 3, is not a whole number. And that's what an integer is, a whole number. And then here is a number machine. The input is here. So this is the number we're going to put in. We then add 6, we times it by 2, and we get the output. Abby says that when the output is 36, so let's put that over here, 36, then the input is 60. Here is her working. So she's subtracted 6, which is the opposite of adding 6, but then she's times by 2. Now, if we were to actually do, so Abby is wrong, explain what she's done wrong. So if we were to do the output is 36, we would need to divide by 2 first, because we'd be going backwards from the end here, and then we would need to take away 6. And that would give us the input. So if we did that, 36 divided by 2 is 18, take away 6 is 12. So she should have divided by 2, and she also should have done it in the other order. So we can say first she should have divided 36 by 2 and then subtracted 6. Drinks and snacks can be bought in a cinema. We've got the prices there. There's a special offer and it says buy 1 drink and 2 different snacks for £3.99. Laura's going to buy 1 drink and 2 different snacks, so she's going to do the offer and work out the most money that she can save by using the special offer. So to save the most money, we kind of want to pick the most expensive combination. If we can make it as expensive as possible, then the deal is going to be even better value for us. So the most expensive option would be to buy the coffee, which is £1.50. And then we want the most expensive snacks. Now, the most expensive thing would be to buy the popcorn twice, but it does specify that we need to buy 2 different snacks. So we can't buy that one twice. So we're going to buy the popcorn at £1.75. And we're going to buy the ice cream at £1.60. We're going to add them together. Now we have got a calculator, so I could quite easily do that one, but I'm going to make the most of having my calculator and add that up. So £1.50, add £1.75, add £1.60, and that is £4.85. So by doing the deal, she's getting it for £3.99. So we're going to say £4.85. How much has she saved? Take away £3.99. Always when you're typing things in your calculator, make sure you're writing them down as well so you can get the method marks. And that's 86 pence. So she's going to save 86p by doing the special offer. And that's the most that she could save because that's the most expensive combination of drink and snacks. So hopefully you've had a read through of this one. I'm not going to read it all, but we've got this path. And Jake wants 6 meters of this path. At the minute, we've got 1.5. So this is the path going along here. And we've got a 1.5 meter pattern. Now, how many times will we need to do that pattern in order to get 6 meters? So if you take 6 meters and you work out how many 1.5s fit into it, then you're doing 6 divided by 1.5. So we need to do that pattern 4 times in order to get 6 meters of path. Now in this pattern, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small paving stones, and we have 3 large paving stones. And we need to do that times by 4 to get 6 meters of path. 10 times 4 is 40 small. And 3 times 4 is 12 large. That's for the whole path. And then we just need to times each of those by the cost of the paving slab. So I've got small ones costing £2.30. So 40 times £2.30. Again, I'm going to use my calculator, but again, I'm writing down what I'm typing in my calculator to make sure that I'm getting any method marks. And that's £92. And then I've got 12 large paving slabs multiplied by £3.65. 12 times £3.65 is £43.80. The total cost is going to be both of those added together. And again, I'm just using my calculator for that. I'm showing I'm adding, okay? And I've got £135.80. Harry designs a different path, and this path is only made up of large paving slabs. Again, we've got 1.5 meters, so we know that to get 6 meters of length, we need to times this design by 4. We've got 6 large at the minute. 6 divided by, so 6 meters divided by 1.5 meters is 4 of these patterns. So I need to do 6 times 4 to get the total number of large paving slabs, which is 24 large. 24 large paving slabs. Now, if you look back to the start of the question, it said that large paving stones are £3.65. So 24 times by £3.65 is £87.60. And again, make sure you're writing down what sum you're typing in your calculator. 24 times £3.65, £87.60. Now, that, Harry is saying, is less than half of Jake's design. So let's go back to what Jake's design cost. Jake's design cost £135.80, and that was in the last question. And if we divide that by 2, £135.80 divided by 2, we get £67.90. So no, £87.60 is not less than half. So no, £87.60 is not less than half. So again, they've asked me a question and I'm answering it and I'm backing it up with the correct statements. Okay, so here we have a pie chart. It's 240 students in this pie chart, and it's all about the students in year 7 and how many girls and how many boys there are. We're told that 177 degrees are girls. If this is out of 240, to know how many degrees each student is worth, I'm going to take 360, because that's how many degrees are in a pie chart, and I'm going to share it between the 240 children. So 360 divided by 240 is 1.5. So we've got 1.5 degrees per student in year 7. Now, then I can say, well, I've got 177 degrees, which represents the girls. So if I divide that by 1.5, I'll find out how many girls there are. And 177 degrees divided by 1.5 degrees is 118 students. So there must be 118 girls in year 7. Which means that the rest, 240, are boys. So 240 take away 118 is 122. So we can write 122 on that side. And we now know how many girls and how many boys we have. Now in year 8, there are 8 more girls. So in year 8, we have 8 more girls. So 126 girls. And there are 32 fewer boys. If we take 32 away, we get 90. So we've now got how many students there are in year 8. And Andy wants to draw a pie chart to show the proportion of boys and girls in year 8. What angle should be the girls? Well, we need to work out what we're out of, okay? How many students are in year 8? So 126 add 90 is 216 students. So we're going to do the same thing we did here. We're going to take a pie chart, which is 360, and divide it between the 216 students in year 8 to get our new pie chart. 360 divided by 216 is 1.6 recurring. Okay, 1.6 recurring. Now that's really important that you pay attention to that recurring, or just keep it in your calculator for now. It's not the same as 1.6. We now just need to times that by how many girls there are. 126 times by that number, 126, is 210. So we should do 210 degrees for the girls. Okay, there are 60 students at a college. 20 of them study both French and Spanish. So we need to put them in the middle of our Venn diagram. 13 students study French but not Spanish, so they're going to go here. And a total of 43 students study Spanish. So that means the whole of this circle needs to be 43, which means we're left with 23 here on the outside. That, however, only makes 56. And we know that there are 60 students at the college from the question. So we're left with 4 on the outside, okay? And that's going to get you 3 marks completing your Venn diagram. One of the students at the college is to be selected at random. Write down the probability that this student studies neither French nor Spanish. So that's these people out here. The probability of me selecting that is 4 out of 60. And you might have simplified that to 1 over 15, but it doesn't matter. We weren't asked to simplify it, so you wouldn't be marked down for not doing it. It's 4 students out of however many there are altogether, which is 6. Jean records the maximum daily temperature each day for 10 days. She also records the number of children going to the paddling pool for each of these 10 days, and we've got this on a scatter graph. So we've got the maximum daily temperature down here on the x-axis and the number of children in the paddling pool on the y-axis. Gene's information for one of these days is an outlier. So an outlier is a point that does not fit the trend of the data. And we can see that this point over here is the outlier that they are referring to. The trend of the data seems to be following this line here, the line of best fit, which we'll draw in a minute. And this point doesn't fit the trend of the data. Give a possible reason for this. Well, we can see that on this day, the temperature is high, but there aren't very many children at the paddling pool. So our reason might be that it was raining. It could be hot or raining, or more likely that it was perhaps a school day. So less children attended because it was a school day. So we just need to give a reason which would explain why on a hot day there weren't very many children at the pool. So it could have been a school day. What type of correlation does the graph show? Well, we know that when the pattern is going up, we have a positive correlation, and when the pattern is coming down, we have a negative correlation. This is definitely going up, so it's a positive correlation. We're then asked on the 11th day, the maximum daily temperature was 19 degrees. Write down an estimate for the number of children going to the paddling pool. Now, 19 degrees is within the range of data that we've already got. Okay, the lowest we've got is on an 18-degree temperature day, up to 24. So I'm happy that within that data range, we have enough of an indication of what's going on. So I am going to draw a line of best fit for that. We wouldn't start to try and guess without drawing a line of best fit. And your line of best fit should go somewhere in between as many of the pieces of data as possible. So I probably should have drawn that a little bit lower because we should try and have the same number of points above and below. But if I took those values away, those points away, that is roughly where it should be. You're then going to go to 19 degrees on the temperature axis, and we're going to go up, hit the graph, and go across. And I get 19. There would be a range of answers that would be acceptable. I think probably 17 up to 20. But we want to make sure that we're showing our working and drawing that line of best fit on and then stating that. It would not be sensible to use the scatter graph to predict the number of children going to the paddling pool on a day where the daily temperature was 13 degrees. So 13 degrees being down here. Give a reason why. That's outside our data range. We don't have any data to support that. Okay, here we were okay. We knew what roughly happened in these temperatures. We don't have any data that goes as low as 13. So it's outside the range of data that we've collected. Simultaneous equations are when we need to solve two equations at the same time. So I need to find a value of x and a value of y such that 4 of the x's and 1 of the y's makes 10. And with the same x and y, the x take away 5 of the y's makes 13. So we're looking for two numbers, an x and a y, that make both of these statements or both of these equations true. Now, the easiest way to do this is to make the number in front of the y's the same, whatever's in the middle. You can make the x's the same, but I would always recommend trying to make the numbers in the middle the same. So at the minute, I've got 1y here, and I've got 5y here. I want to make them both 5 because 5 is the first number in the 1 times table and the 5 times table. So I'm going to times the top equation all by 5, and I'm going to keep the bottom equation all the same. So rewriting my top equation, I have 20x add 5y is 50. And my bottom equation in this case is staying the same. We then, same signs subtract, add if different. Same signs subtract, add if different. And you're looking at the signs of the thing you made the same. So if you made the x's the same, it's positive and positives, they're the same, and we'd subtract. But because we've made these things the same, we're going to add, because we're going to add if they're different. I've got a plus and a takeaway. So I'm going to add, turn it into a big sum, and show really clearly that we're going to add these. 20x add 1x is 21x. 5y minus 5y, well, that cancels out. That's the whole reason why we've done this. And that equals 63. 50 add 13. If 21 times x is 63, we've got 21, 42, 63. So x is 3. We've divided both sides by 21 to get x equals 3. So x is 3. And once we know that x is 3, we can then use that to work out y. So I'm going to go back to the first equation up here, and it doesn't matter which one you use. You can use either of these equations. 4x add y is 10. But we now know that x is 3. 4 times 3 is 12. So we know that 12 add y is 10. Take 12 away from both sides, and y is minus 2. And we can check it in this equation to check that it works. 3, take away 5 lots of minus 2, which is minus 10. 3 minus minus 10 is 13. So it works in both equations, and we found our values. And last question, Samir invests £350 in a savings account. He gets 2% per annum compound interest. How much money will Samir have at the end of his account at 3 years? Compound interest is a really good one to teach yourself, and look it up on Hegarty Math if you're not sure how to do it. It comes up most years, and it's just a case of learning the rules of how to do it. So we start with the amount of money, £350, and we times it by the multiplier. Now, to work out the multiplier, we have 100% of our money in the bank, £350, and we want, in interest, we get an extra 2%. So that means we want 102% of our money. 102% as a decimal is 1.02. That's our multiplier. So I'm going to times by 1.02, and we do the power of the number of years, 3 years. So it's going to be 350 times 1.02 to the power of 3, and we've got our calculator for this one. Let's put it here so we can see it. I'm going to type 350 times by 1.02 to the power of, use this one here where you can type any power you like, and 3, or we could use the cube one to be fair for that one. And that is 371.4228. I'm going to write that here, but then because we know we're dealing with money, I'm going to round it to 2 decimal places. So my final answer is £371.42, because this 2 would round down, so it's just going to stay the same, and that's our final answer.